What are voltaic cells? A voltaic cell is often called a galvanic cell. It converts chemical energy into electrical energy. By separating the two half reactions and having the electrons transfer to the reduction side over a wire, the cell produces electricity. Electricity is the flow of electrons over a wire. A cell must separate the half reactions in order to have electron flow produce electricity. One side contains the reactants for the oxidation reaction, while the other side has the reduction reaction. Electrons flow from the oxidation compartment to the reduction compartment. Metal and a wire are needed to conduct the flow of electrons from one side to the other. If the redox reaction includes solid metals, these can be used to conduct electrons. If not, a non-reactive metal, such as platinum, can be used. Reduction occurs at the cathode. Oxidation occurs at the anode. If electrons flow, a negative charge may build up on one side. When a large enough charge is built up, electrons cannot continue to flow. They're repelled from the negatively charged compartment. A salt bridge is added that allows ions to flow to balance the charge. The cell can now operate for a longer time before charge builds up or reactants are used. Line notation is a shorthand method for describing chemical cells. The oxidation reaction, the anode, is always written first, followed by the cathode. You can remember this because the A for anode comes before C in cathode in the alphabet. Reactants are always written first, just like in a chemical reaction. The two compartments are separated by a double vertical line. Different states of matter are separated by a single vertical line. Species of the same state of matter are separated by a comma. For example, write the line notation for this reaction. Magnesium is the oxidation reaction, going from 0 to +2. Aluminum is the reduction reaction, from +3 to 0. The oxidation reaction, the anode, is written first. Its reactant is written first. Mg solid, vertical line to separate the states of matter, Mg +2 aqueous. Double vertical line to separate the anode from the cathode, aluminum +3 aqueous. Vertical line to separate states of matter, aluminum solid. What type of calculations are used with voltaic cells? Electricity is measured by volts. The volts measures the potential energy difference from where the electrons were before the transfer to where the electrons are after the transfer. This difference in potential energy as the electrons move is how we measure electricity. The standard reduction potential is the electromotive force produced when compared to hydrogen. Hydrogen has been set as the standard with an EMF of 0. Everything else can then be compared to it. How is standard reduction potential used to find the EMF for a specific cell? The table lists standard reduction potentials. An oxidation reaction is the opposite from this reduction. Therefore, the oxidation potential is negative reduction potential. The EMF for the cell is calculated by adding the reduction potential of the reduction half reaction to the opposite of the reduction potential for the oxidation reaction. You can also think of this as cathode minus anode. A cell will always proceed spontaneously in the direction with a positive EMF. For example, determine if this cell will react spontaneously. Fe plus 3 to Fe plus 2 is reduction at the cathode. Copper to copper plus 2 is oxidation at the anode. Look up the standard reduction potentials for these two reactions. The iron reaction is 0.77 volts. The copper reaction is 0.34 volts. EMF is equal to the cathode minus the anode. This means iron minus the copper. 0.77 minus 0.34 volts is equal to 0.40 volts. Because this is a positive EMF, this reaction will proceed spontaneously as it was written. Electrochemistry calculations also use stoichiometry. New units, such as amps, which measures the charge per second, and Faraday, which measures the charge on electrons, can be used as equivalents in electrochemistry stoichiometry. For example, if 10 amps is passed for 30 minutes through a copper plus 2 solution, how many grams of copper would plate out? 10 amps is the same as 10 coulombs per 1 second. 96,485 coulombs, the Faraday constant, is equal to 1 mole of electrons. The balanced equation means that 2 moles of electrons are necessary for every 1 mole of copper atom that becomes neutral. The atomic mass for copper is 63.54 grams. We begin with the information that we will run the current for 30 minutes. We're looking for the grams copper that will plate out. First, we need to change minutes to seconds. Next, convert seconds to coulombs using the knowledge of 10 amps, 10 coulombs for 1 second. Next, coulombs can be converted to moles electrons using the Faraday constant. Moles electrons can be converted to moles copper by using the balanced equation. And finally, moles copper can be converted to grams copper using the molar mass. The answer is 5.93 grams copper. What is electrolysis? Electrolysis is the opposite process, using electricity to force a chemical reaction in the non-spontaneous direction. An electrochemical cell is a cell that converts electricity to chemical energy. If the spontaneous process produces 0.44 volts, then you have to put in at least 0.44 volts to get the reaction to proceed in the opposite direction.